So whenever you are going to, this is 1.1-1, we're finishing up that lesson today. And so whenever you are asked to use a protractor, so you are going to use, if I ask you to draw an angle, most of you would probably just use your pen and just draw, you would just draw an angle like this. Now, what I'm going to ask you to do is take a little bit more pride in your work, especially now, and instead use the bottom of the straight edge. So it's hard for me using this program, but use the bottom of your straight edge to then draw your straight line. Oh, I was doing really well to that last part. That was really good. Y'all are not impressed enough with how well I was doing. Yeah, that's devastating. But so you are going to use your straight edge to help draw an angle. So what I want you to do is just draw some random angle. Please do not draw a 90-degree angle. Draw an angle. Now, what is going to happen to you when you draw an angle is you are going to draw an angle. And when you go to use your protractor, when you draw this angle, and I'm going to teach you how to measure it. Whoops. Come on. When I teach you how to measure it and show you how to line up everything, what do you notice is an issue? And I'll talk to you about how you're going to line it up. What do you notice is an issue about this line? It's straight. It's not long enough. So one thing that you are going to learn is you are going to take your straight edge. You are going to rotate your straight edge. This is how I have to do it. And I'm going to use the straight edge to then help extend my line. Does that make sense? I'm going to use the bottom of this, and then I would actually go ahead and take this line and extend it so that it's longer. Does that make sense, yes or no? Now when I line this up, do you notice how I can tell what type of angle this is? You see how I can actually see that it extends and hits where it needs to. So your first lesson is if your angle is not long enough, what are you going to use? The bottom of your straight edge to do what with the angle? Extend the lines. Does that make sense? All right, next, notice, do you see on the bottom of your protractor, there might be a hole at the bottom? You might have like a protractor that's got a hole like this at the bottom. You might have one that looks more like this, where it's got this at the bottom. Wherever this point is, whether it's a hole or this right here, that's where you're going to line up with the vertex. So you'll see I keep putting that spot right on my vertex. And then what am I also making sure with this protractor, because I can rotate it, not only am I making sure that that spot is right on the vertex, but where else am I making sure that my bottom line is matching up with? What is my bottom line on? What's it touching over here? No? I don't care about the 180. What's the other one I care about? I'm pointing to it. What number is right there? 0. You're going to make sure that this bottom line is lining up with that 0. So if that was my bottom line, do you see how I'm lining it up with the 0? You follow, yes or no? Mm-hmm. And then when I go and I measure this, since 0 is do you guys notice that there are 2 sets of numbers, a top and a bottom number? Where is my 0 when my line is going this direction that it's going? When my line is going this direction, which one of these is 0? The bottom numbers or the top numbers? So that tells me I'm using the bottom numbers to measure this angle. Do you follow? So what is the measure of this angle? 120, and then 1, 2, 3, 4, right around 125 degrees. What happens if I have an angle like this? Actually, let's do this. So what if my angle looks like that? Well, I'm going to take my protractor. Again, I'm going to drag this thing and I'm going to put it that spot right there on the vertex, yes? What else do I need to do with my angle or my vertex or my protractor? So I've got to kind of turn it and line it up so that you see the line is touching the zero now. Yes? Now, which one is the zero? Is the zero the bottom numbers or the top numbers? Where is this line touching the zero? On the bottom or the top number? You see it's the top. You see how the top number is where the zero is? The top number, come on. The top number is the zero. So guess what set of numbers I'm using to measure this angle? The top or the bottom? The top. And so what is the measure of this angle? About 50 degrees. Does that make sense? If I asked you to draw an angle, what if I asked you to draw a 50-degree angle or a 42, let's do a 42-degree angle. What do you think you're going to start off with on your paper? And how are you going to draw that line? You're going to use a straight edge. You're going to draw a line. So everybody see how I drew my line. Then I'm going to put my protractor on that corner. That's where my vertex is going to be. Does everybody see that? And if I want a 42-degree angle, does everybody see this is where 40 is right here? Yes? So I'm going to go over from that 2 tick marks. 1, 2. So right there, I'm going to put a dot. And what am I going to use to connect that? How am I going to make this to where I connect this with that? I'm going to use the bottom of my straight edge, and I'm going to connect the vertex. I'm going to extend it through that point that I just drew. And there I go. I now drew a 42-degree angle.
My personal favorite angle is 45.
I like it. Any questions on how to measure an angle? Do you have questions on how to measure an angle using your protractor? Does anyone have any questions on making a certain angle? Yes.
I actually do because so like are we supposed to like line up the protractor like with this also with this line?
Yes. For yours, that will be where zero is.
Alright.
There are little subtle differences in the protractors. That's why we were talking about lining it up and making sure that bottom's on zero. Do you have a question? Measuring them. Yes. Here's what I want you to do. So the last thing we're going to talk about is what we call angle addition postulate. So here's what it says. I'm going to draw a picture of it. If you want more of a formal definition, it is in your book. But it's basically like this. If you have I'm not cutting today. I will collect tomorrow. Postulate. So it's like post, you, late. So if I had something like this, then here's what the angle addition postulate says. Do you think you guys can come up with the angle addition postulate with me? Okay, what do you think happens? angle,
They have to be a part of the same angle.
okay, so let's,
So if you could call it angle A, B, C, and then B would still be in that angle, correct?
that will be our final one. We're gonna say angle, and when we name angles, you did a great job. I'm gonna call it angle A, D, B. Does everybody see that that is the top angle? What if I add that to angle what?
Angle B,
B, I'm gonna just start where I ended, B, D, C. So what am I saying? If I take this angle right here, this one that I'm drawing in red, and if I add it to this one that I'm drawing in green, what will that equal? Angle, I can't call it AC, because that would just be a line. Remember, we have to use 3, and the vertex has to be in the middle, so we would call it ADC, and that would say those two together would add up to be that big angle. For angles, we use 3. For lines, we only use 2. For rays, we only use 2. Okay? Your homework, you're going to practice naming those things. No, the homework that was on that. If you don't remember what you're supposed to do, how can you help figure it out? Go back and look in your book. It shows you how you're supposed to name all those things too. Okay? You should have your book out, your notes. Hey, we're not finished yet. So, I'm going to read this problem. This is example 5 from the book. A lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees to the right or to the left from the shown starting position. The beam of light from the spotlight forms a 22-degree angle. Can the designer use the spotlight to reach each object that is on the stage? So, they draw a picture for you. Looks like this. This is in your, this is a chair. This is a rug that needs to reach. And then there's a door it needs to reach. And then there's a table over here. And what do you think the region that is yellow is?
Region that I can
angle from.
That's where the spotlight is currently. That is where the current thing is. The spotlight is.
Move it backwards.
Okay. Yep. That's what it's supposed to say. It also says that from here to here, oops, from here to here is 74 degrees. From here to here is 57 degrees. And we want to know X, and we need to know Y. Ooh, I lied. Oh no. Baby coming back. I'm trying to figure out what they told us. All right, here's what we're gonna do. If I know that this is 25, let's say I know this is 30, and I know this whole thing is 100 degrees. This is an easier one. How do I figure out what this is? How can I figure out what this angle is worth? I take 100, and what should it equal? Well, we'll call this x, yes? So it'd be x plus what? 25 plus, and then we would go 100 equals x plus 55. So then we minus 55, and we could realize that x was 45. That's one way that we can use the angle addition postulate. What did I show you yesterday? Are you always going to use this the same exact way? No, but is the idea or concept the same? So like they could give you something like this. This is 3x minus 7. This is 2x plus 3. And they could say this whole thing is 75 degrees. Then they could say I'm going to give you this problem. What is the measure of angle? The measure of angle A, B, C. That is your question. You're solving that on your own. What is the measure of A, B, C?